In this video, I'm going to walk you through some sample differential leveling calculations. So we're just going to run a level loop example. So this is what it looks like. You can see we have an oak over here, so that would be like an oak tree. Over here, we're going to an elm tree, and you can see that those are described on there. We have our pace constant set up. We've located, where these trees are in relationship to some routes over here and a building over there. We've kind of given our description of what that oak tree looks like. It's got a spike put into the tree and some dimensions given there. And we'll walk through how to set up this level loop and then how to do the calculations that go along with it. So we're going to do a forward run down here on the bottom part, and then we're going to do a backward run back that way. So hopefully when we go from oak to elm and back to oak, we end up finding the same elevations forwards and backwards. That's the idea, at least. So some general rules when we talk about doing level calculations, we start with our benchmarks, right? And so that's, our areas where we start. We want to put some type of a wording description. We can sketch or even take a picture so that we know where those benchmarks are so that somebody else could come out and find those later on, right? So when we describe our benchmark, we need some kind of a designation. BM HYD1 might mean that that's benchmark 1 HYD for hydrant. Give it a name that makes sense. Don't use some just weird something or other. Give it a name, whether it's a bolt, pipe, a hydrant, a spike, something that makes sense later on. Some type of a location, in relationship to a particular intersection in a town. Make sure that you use compass directions. Where at on that did you take the benchmark from? If it's a fire hydrant, did you use the bottom, the top, a particular valve stem? What part of that benchmark did you use? Is it painted at a particular cover? Painted a particular color. Make sure that you identify that so you can come back out later and find it. And then typically we pick those benchmarks because we have a known elevation. So you need to mark on there whether it was a known elevation or an assumed elevation, and you'll get that kind of information from me when we do our field experiments, but you need to mark that as well. And then, put some kind of value at that. Whatever your known datum point is, you want to make sure that you write that down and tell us whether it's an assumed elevation or if you found it on a map somewhere. Very important to understand how that works. We also need to have some type of a compass, right? Remember we talked about all of our sketches need to have north arrow pointing hopefully north or up on our paper, right? We need to have that there for reference. We always make sure we put a north arrow in. You guys understand exactly how that works. We want to make sure that we don't use the words left or right. The only time we use left or right is when we're talking about we started north and then we headed in a particular direction from that point. So just keep that in mind. All of our sketches need to have a north arrow pointing to the top of our paper. So we're going to start at that oak benchmark. So that benchmark, again, is a permanent point of known elevation, somewhere that's not going anywhere, and it has a known or an assumed elevation when we start. So there's our oak tree. That's kind of what it looks like. Right in here you can see that. Approximate size, where that elevation is, how far off the ground that elevation is, a good description of that known benchmark. There's our compass rose. So we have some verbal description there of how, if somebody needed to go out and find that oak tree, hopefully they could use these descriptions and figure out where it was that we started. Okay, so those verbal cues and directions are important that we have that information in there. And so There we go. You might even take a picture of it if you have to, but some kind of a good description needs to be in our field notes so that we can locate where we started. So now we're getting ready to do our forward run. So we're starting over right here at this benchmark oak tree, and we're working our way forward to our elm tree. So that's the direction that we're working in. So SU is for setup. So we're going to set up here, and set up here. And as we go, we're going to have, that's the direction we're working toward with our setup. So as we get larger, that tells you the direction that we're going. We start at 1 and end up at 3. So we're doing that forward run. So right there is our benchmark. Okay. So we're going to take a back sight onto that benchmark. So if this is our setup, right, this is where our instrument is, we're going to take a back sight. So remember, our forward run is going over this way. Over here is where our elm tree is. So this would be a back sight. So that's the first measurement we take from our instrument setup here back onto that benchmark. So a BS on our benchmark oak. So we're going to look at our rod reading. Our rod is set up right here. We're going to look at it, and we're going to take a value right there. So what is that value? 5. So you can see here with the red, we're at 5 whole feet, 0.4, 2, 3, 4. 5.44 is our reading that we're going to take. Okay, we paste that. All right, and then we bring our rod over here to turning point 1. We paste that as we go as well. And so now we're taking, our instrument hasn't moved, it's still right here. Our rod has moved, now we're up here, and we're taking a FS or a foresight, front sight on turning point 1. So that's what we look through the instrument, and this is what we see. So our reading then on TP1 or turning point 1, our foresight on that is 0.98. So we're not at a whole foot because that would be up here, right? So we're at 0.9. There's 1, 2, 3, 4, 5, 6, 7, 8. So 0.98 is our front sight on turning point 1. So in our field notebook, this is what we would see. So we start out with an initial elevation. So there's our assumed elevation that we know, right, for our benchmark at our oak. This is what it looked like, right? We had our known elevation, okay? Then we put our level rod up. We have our instrument here. We're taking a back sight onto that benchmark, and we read 5.44. So that 5.44 goes up here. It is a back sight onto benchmark oak. So that's where that number goes in our field notes. Now we're ready to calculate our height of the instrument, our HI. So the height of our instrument now is going to be our benchmark elevation plus our back sight. That's going to give us our instrument height. So this distance up here is what we're talking about, right, when we add those two numbers together. So our instrument height is 756.02. We add this number here and that number there. That's what we get. Okay, so that's where that value goes. We paste it off. So that's 61 paces. That's going to go over here under our back sight paces. And now we're ready to pick the rod up and move it over to turning point 2. We're going to measure our paces as we go, see where those go. Our foresight paces on turning point 1, that's where that's going to go. We've moved our rod now, and now we're going to take a shot over here. So we set this up, we left it alone, we took a back sight, we spun it around, and now we're taking a foresight onto that level rod at turning point 1 or TP1. So we looked at that. We got our reading of 0.98. So what do we do with that 0.98? It goes right up here. So under turning point 1, we took a foresight, and that's where that value goes right there, 0.98. So now we're ready to calculate the elevation then at turning point 1, and that elevation is equal to the height of the instrument minus the foresight, because remember the height of the instrument is right up here, at 756.02, and if we subtract that value of the foresight down, that's going to give us the elevation right here at turning point 1. So that value then is 755.04, and that is then our elevation at TP1. So now we've completed our first instrument setup. Okay, so you can see the order that we did. We've got some blank spaces up here. Okay, that was our initial first setup is now complete. Now we're ready to pick up the instrument and move it. So be careful over there. You're going to leave some lines in there blank. So just be aware of what lines you're leaving blank. And notice that we've left a row in between each one of these stations as we go along over on the left. So that's important that you leave in those blank lines. So now we're ready for our second setup. So again, we're moving from this direction to this direction, from the oak toward the elm. So that's our forward run. That's the way we're headed, right? So we're going to take a back sight on turning point 1. We're going to read our rod. That's 7.05. We pace it as we walk with our rod, because our next rod level is going to go over to turning point 2. We pace that as well. So now we're taking a foresight onto that rod that's at turning point 2, and we have a reading there of 1.82. All right, so now we're ready to put that information into our field notebook. So at turning point 1, that was our back sight, and now we're ready to move on to our next step, which is the instrument height. We calculate that. This value right here is equal to the elevation plus the back sight gives us our instrument height. Okay, so that was what we needed to calculate there. We put in our paces for our back sight. There's our paces for our front sight. There's our value then for our front sight, and now we're ready to calculate the elevation of our front sight. So to calculate the elevation at turning point 2, this value right here is equal to our instrument height minus our front sight. Okay? Instrument height minus our front sight gives us our elevation at turning point 2. Now we're ready to pick up the instrument and move it again. So now we're at setup 3. Okay, we're almost to that benchmark elm. We do our back sight on turning point 2. We get a reading of 6.57. We pace it. We pace to the next turning point, which happens to be our benchmark of our elm. We pace that. We look at a foresight onto our elm, and we get a value of 1.55 feet. So now we're ready to take those values in. There's our turning point, 2 back sight. Now we're ready to calculate our instrument height. So we take the previous elevation plus our back sight gives us our instrument height. We put in our paces for our back sight and our forward sight. Then we take our next foresight reading. That was on the elm tree. And now we're ready to calculate the elevation of the elm tree. So that one would be our instrument height right here minus our foresight. We get 755.29. So now we're at a new benchmark, that elm tree. So we want to make sure that we've described that elm tree in relationship to the other things that are around there. So you can see it's a nail set vertically into a large root on the west side of the elm tree, the approximate size of the tree, give it a good, proper description. Now we're going to work our way backwards from the elm tree back to the oak tree. So this is going to tell us, we went forward and got the elevation of the elm. Now we're going to go backward and we're going to see where we started and where we finished if those numbers are the same. Hopefully they are, but there's a little bit of error involved, right? So now we're working our way back that direction. So we're going to treat that elm just like any other turning point until we need to figure out some elevations then to close the survey. We're going to use that a little bit differently. So it's just like right now, we're going to treat that elm like any other turning point in our survey. Okay? So now we're going to work backwards a little bit. So we took a back sight then on our elm. Okay? There's our back sight, 0.83. That's where that goes in our field notes. We calculated our instrument height. We paste. Now we're going to take a front sight then on turning point 3, 7.14 is our value up there. We calculate our elevation at turning point 3. Now we're going to take a back sight, 1.42. Calculate our instrument height, pace to turning point 4. We are at 6.46. Calculate our elevation. Now we're taking a back sight on turning point 4, 2.07. Calculate our instrument height, pace. And now we're back to our oak tree, and we're going to take a foresight then on that oak tree, and we are at 5.47. Calculate our elevation of our oak tree. So when we look at this, you can see now we started out with a known elevation of 750.58 on that oak tree. And then when we went all the way around and came back, now we said that elevation was 750.54. So we're off just a little bit. And that's where thinking about our error and calculating how precise we were in these surveys becomes important. Okay, now we're going to do our math check and do some closure calculations and figure out how we're going to distribute that closure error throughout our survey. Because we know that the elk tree nail hasn't moved, that spike is still there, so it hasn't changed elevation. So somewhere in the mix of all this, we have to look at our error, figure out if it's acceptable for the class of survey we're doing, and distribute that error along